This is Stephanie from statisticshowto.com. In this video I'm going to show you what a z-table is. I'm going to start by building a very simple z-table from a bell curve. A z-table tells you the area underneath a bell curve. Now on a standard normal distribution, this center area from one standard deviation above to one standard deviation below the mean, this is 68% of the data in a normal distribution. Now a z-score is exactly the same as a standard deviation. So a z-score of 1 would be in the same place as a standard deviation of 1. Here's a z-score of 2, a z-score of 3, -2, and -3. So you can see that these are the same as standard deviations. Now a z-table won't give you the central area, but what it will give you is the area going from the left like this. So if you look up a z-score of 0, in the z-table, that will equal 50%. But in the z-table, it's going to be a decimal, 0.5. 0.5 is 50% written as a decimal. If we go out to a standard deviation of 1 or a z-score of 1, well, now we've got that 50% plus we've got half of this 68%. We've got 34% here, 34% here. So 50% plus 34% is going to equal 0.84. A z-score of 2, well, the 68, 95, 99.7 rule tells us that from -2 to 2 standard deviations, this is going to be 95% of the data in between -2 and 2 standard deviations, or a z-score of -2 and 2. So if the whole of this area is 95%, then 1/2 of the area, 95 divided by 2, is 47.5. So I've got 50% here, 47.5 there, -97.5. So if I look up a z-score of 2, I'm going to get 0.975. This is a very simple z-table. If you look at an actual z-table, it's going to look something more like this. Well, I said a z of 0 was 0.5. And we can check that in the actual z-table. A z of 0.0 is 0.5. My z of 1 was 0.84. If I go down to a z of 1.0, and notice I'm in the 0 column, I get 0.8413. So I was close, but 0.8413 is more exact. And if we go out to 2 standard deviations, a z-score of 2, we've got an area of 0.975 or 97.5%. So if I go down to a z of 2, it's 0.9772. So I was a little off, but the 68, 95, 99.7 rule is pretty approximate. The z-table will give you more exact values. Let's just take a random area here. I'm going to take 0.8907. That is saying under the curve, it's 89.07% from the left. And that is going to happen at a z, or a standard deviation, of 1.2. Going to go up the column 3. 1.23. So 1.23 is going to be somewhere between 1 and 2. Probably about here. So remember, the z-table is going from the left. So this is telling you that about 87% percent of the area is before 1.2 standard deviations. Well, what if this was reversed? What if I wanted to know at what point on the graph will I find 65.2% of the data? Well, it's going to be less than 87. It's going to be approximately here, somewhere, I don't know where. But I can use the z-table to look up this 65.2 and find out exactly where this point is going to be. I'm going to look in the center of the table for 65.2, or as close as I can get it. I've got 64.06. Looks like the closest I'm going to get it is here. It's on the 0.9 column and the 0.3 row, so that would be 0.39. So this line right here is going to fall at 0.39 standard deviations. A source of confusion for many students is that you'll see different z-tables. You'll see a standard z-table, sometimes just called a z-table. You might see a right-hand z-table and a left-hand z. Well, the standard z-table is going to give you this area from the left all the way over to some point on the right. The right-hand z-table gives you the area from the mean in the center to some point on the right of the bell curve. So if you were to look up say a standard deviation of 1 or a z-score of 1 in the right-hand z-table, you would only get this area here, which would be 0.34 in the z-table, and you would want to add this 50% on to get 0.34 plus 0.5, that's the 50%, and that would give you an area of 84%. And finally, the left-hand z usually just gives you the area in a tail, like the left tail here, from some negative point in the distance to a z of -2 or -2 standard deviations. So basically a z-table is going to give you the area under a curve. It's going to help you figure out the percentages of data items that fall in a particular point, a particular standard deviation away from the mean. Check us out at statisticshowto.com for more videos and articles on everything elementary statistics.